I've been getting a lot of questions about Kubernetes, like how can I run Kubernetes if I don't use the cloud? And can I run Kubernetes on my own servers? When you have your own physical hardware, you may create throwaway virtual machines to run your workloads. It helps decouple your application from your hardware. As long as every virtual machine can see each other on the network, we can bootstrap Kubernetes and form a cluster, and Kubernetes can run our apps on containers. Rancher allows us to run Kubernetes on our own hardware or virtual machines. Rancher also allows us to manage our Kubernetes clusters, even ones in the cloud. Today we're going to be taking a look at the basics of Rancher. We're going to spin up my own virtual hardware and bootstrap Kubernetes from scratch. We've got a lot to cover in this video, so without further ado, let's go. So if you take a look at my GitHub repo, I have a Kubernetes folder, and inside there I have a Rancher folder with a README. And here we have our introduction to Rancher for on-prem Kubernetes. Now because I don't have my own hardware, I'm going to use Hyper-V to prepare all my instances on virtual machines. Then I'm going to create a Hyper-V network, create all our virtual machines, go through all the setup, and eventually take a look at Rancher, deploy a cluster, and how to manage that cluster. So be sure to check out the link down below to the source code so you can follow along. Now before we take a look at Rancher, we're going to need our own infrastructure. Now there's multiple ways of doing it. At a minimum, you're going to need Linux machines, preferably with Ubuntu. Now you can have your own hardware and install Linux directly on that hardware. Or you can use a hypervisor like Hyper-V or any other kind of hypervisor to bootstrap virtual machines on your own hardware and use that to bootstrap your Kubernetes cluster. The benefit of using virtual machines is that they become throwaway and immutable, meaning we don't directly tie ourselves to the operating system. If we do Kubernetes upgrades, we can simply roll out new virtual machines. So firstly, we're going to need some Linux virtual machines. We're going to be using Ubuntu, and the second requirement is all these machines have to be able to talk to each other on the network. So first things first, we're going to need to prepare our infrastructure, and in this demo I'll be using Hyper-V, and I'll be using this to create virtual machines to run my Kubernetes nodes. Now there's a few points to note here. The benefit of using virtual machines is that we can decouple our application from the hardware. It makes maintenance much easier. When we need operating system upgrades or a new version of the operating system, we can simply roll out new virtual machines and throw the old ones away. So ideally we reduce the lifespan of virtual machines and we don't keep them around for a long time, otherwise they become snowflakes. Ideally the bare metal becomes your compute. Now although you can install Linux directly on your bare metal, we'll be using virtual machines in this example, which means I don't want Kubernetes running directly on my bare metal machines because I want my machines immutable. If you prefer to install Kubernetes directly on your hardware, Rancher will still work for you with the same instructions that I'm going to be following. Now the default Kubernetes requirements is that all virtual machines are able to see each other. So if you're planning to use a hypervisor to create virtual machines or you're installing onto bare metal, you need to make sure that those machines can all see each other on the network. So with the basics out the way, the first thing we're going to do is create a virtual network so all our machines can see each other. Now I'm going to do that in PowerShell. So I'm going to right click and I'm going to open PowerShell as an administrator. Now because my machine has a network card, I need the details of that adapter. So I'm going to say get net adapter. Now we paste that into PowerShell and we can see it's coming back with Ethernet 2, which is my network card. So what I want to do is create a new virtual switch using my network card so all the virtual machines can run on that network. So the name is Ethernet 2. Now to work with Hyper-V and PowerShell, we're going to import the Hyper-V module. So I go ahead and import that module, and then I'm going to go ahead and grab the net adapter we just printed out. So I specifically want the Ethernet 2 adapter. Go ahead and paste that. That'll be stored in the Ethernet variable. And then what I'm going to do is create a new switch where all my virtual machines can run on. So I'm going to say new VM switch. The name is going to be virtual network. I'm going to pass in my adapter. I'm going to allow the operating system to manage it, and the this is going to be my shared virtual network interface. Go ahead and copy this into PowerShell, and that will create my network switch. So we can see that's been created, and now we have a network where our virtual machines can run on. Now the next thing I want to do is open up Hyper-V Manager. So I open up Hyper-V Manager, and in the Hyper-V Manager page we can open up the virtual switch manager, and we can see our new virtual network switch has been created here, and it's using my network card. So you can also use the GUI to create the switch as well. So now that we have a virtual switch, let's go ahead and create 3 virtual machines and run them on that network. So the first step I would recommend is to go and grab the Ubuntu server image. So I go over to ubuntu.com, download/server. So I want the server image, and I'm going to go to option 2, which is the manual server installation, and this will take you to a page where you can download Ubuntu server LTS. I'm going to go ahead and click this guy and download the ISO file. And to make this very simple, I've gone ahead and downloaded the ISO and placed it in my temp directory under the C drive. Now, as I mentioned earlier, feel free to skip this step if you already have virtual machines. If you want to use something like VirtualBox or another hypervisor, go ahead and use those technologies to create yourself 3 virtual machines with Ubuntu server. Or you can install Ubuntu server on your own hardware. So to create our virtual machines, it's very simple. I'm going to create 3 directories, one called Linux 0, Linux 1, and Linux 2. I'm going to create them in the temp directory, and this is where we're going to store all our VM data. So I'm going to go ahead and create the first directory for the first VM, the second one for the second VM, and the third one for the third VM. So I have Linux 0, 1, and 2. Then what I'm going to do is create new virtual hard drives. So I'm going to create new VHD in each of the respected folders, and the file is of type VHDX, and the size is 20 gigabytes. So I'm going to create very small disks in this demo, but remember, you might need larger disks if you're going to be running a lot of containers on this machine to prevent it from running out of space. So I go ahead and copy this command, and I'm going to paste it in my PowerShell window because it needs to be running as administrator. That will go ahead and create our first disk. I'm going to copy the command again to create our second disk for the second VM and the third disk. So now in our temp directory, we have a VMs folder, we have Linux 0, 1, and 2, and in each of these we have a virtual hard disk ready to go. Now to create the virtual machines, it's very easy. We call the new VM command, and we have to do this 3 times. The first machine's name is going to be Linux 0, generation 1. We're going to give it memory of 2 gigabytes per node. If you have larger work nodes and you need more memory, you're going to need to up this number. I'm going to tell Hyper-V that I want this VM to be part of the virtual network switch we created earlier, and I want to use the VHD that we created earlier as well. So I'm attaching each of these virtual machines to their respected hard drives and the path where I want the VM to store its metadata. So I go ahead and copy this command, I paste it to my PowerShell window, and that's gone ahead and created the machine, and notice that it's off. So we need to still install the operating system there. I'm going to go ahead and copy the command for the second VM, paste that in, and now we've got the second VM. Copy the command for the third VM, paste that, and now we've got the third VM. If we open up the Hyper-V Manager, we can see we have 3 machines and they're all off. Now to install Ubuntu on each one of these machines, we have to set a DVD drive for each one of those machines and mount our ISO file. So I'm going to say set VM DVD drive. I'm going to call it Linux 0, controller number 1, and I'm going to pass in the path to that ISO file that I downloaded. I copy paste this to the terminal, and that'll create our VM DVD drive for the first machine. I go ahead and copy the second one, and I go ahead and copy the third one, and now we have 3 VM DVD drives. And the final thing is what we need to do is just start up all our VMs. So I'm going to say start VM Linux 0, and I'm going to start this up in PowerShell. That will go ahead and start the machine. Then I'm going to also start Linux 1, and I'm going to start Linux 2. And if we go look at Hyper-V now, we can see the status running. So these VMs are now starting up, and they're ready to follow the setup process for Ubuntu. So the easiest way to configure Linux on all 3 of these machines is to double click each one of them. It'll open up the setup page as we can see here. So this is Linux 0. So I'm going to go ahead and perform these operations on Linux 0, and then I have to repeat it on Linux 1 and 2. So you can see this is the basic setup. So we pick English language. What I'm going to say here is I'm going to install without updating, and I'm just going to say done. And this is my network adapter. You can see the network adapter it's detecting, which is eth0. I'm going to go ahead and say done. I don't want any proxy addresses, so I'm going to say done. This is the mirror address where it'll download the Ubuntu packages. I'm just going to leave that as the default. And here it is going to set up its disk. So what I'm going to say is use the entire disk, and you can see it's picking up the 20 gigabyte disk that we've allocated. And I'm just going to tab through and then go to done and hit enter. And over here it's giving me a summary of the file system that it's got 20 gigabytes. I'm just going to again press enter to say done. It'll ask you to confirm destructive action, which basically means it's going to go ahead and format that 20 gigs of space. And I'm going to hit tab to say continue. And now I have to give username details. So what I'm going to call this one is Linux 0. The server name is going to be Linux 0 as well. The username is going to be Linux 0. And I'm going to give it a password and confirm the password. And then I'm going to say done. So what I'm going to do is I'm not going to add any software to this VM from the defaults that it's providing. So I'm going to say no, I don't want SSH server. You're going to see all of these defaults. Although we're going to need Docker, please note not to go ahead with any of the defaults here. So I'm not going to say that I want Docker over here, because this will install the package of Docker that's shipped with Ubuntu. And what we're going to do is we're going to install the latest Docker version from Docker itself. So make sure you skip these features, and we'll go ahead and configure this server later. So I'm going to go ahead and click done. And I'm going to let it run through the install process. And once install is fully complete, you will see a reboot now button. So what I'm going to go ahead, I'm going to say reboot now. And what you'll see is that you'll get error saying fail to unmount CD-ROM. So this means everything is done. What we need to do now is shut down the VM and reboot it from Hyper-V. So I'm going to go ahead and shut it down. I'm going to right click on Linux 0 and say turn off. And I'm going to go ahead and turn it back on. And when I double click it, you'll see it will run through a bunch of prompts and will eventually ask you to log in. So I can log in by saying Linux 0 is my user, and I can give it my password. And now I'm in. So what I'm going to do now is quickly fast forward and do Linux 1 and 2. Basically just repeat all these steps. And now I have all three virtual machines up and running, and you can see I have a terminal connected to each one of them. Now for Rancher to work, we firstly need some machines that are all on the same network. The second requirement is that we need Linux on these machines, which we have Ubuntu server. The third requirement is that we need Docker installed on all these machines. Now for demo purposes and making this a little bit simpler, I'm going to go ahead and install SSH on every virtual machine. This allows me to SSH to each one, allows me to install Docker, and allows me to bootstrap and install Rancher. Having SSH makes it a little bit simpler because I can copy paste the bootstrap commands. Running in Hyper-V, because I'm running Ubuntu server, I don't have enhanced sessions enabled, so I can't copy paste. So let's go to each machine and set up SSH. So we're going to say sudo apt-get update. That'll ask us for a password. Go ahead and run update. Then I'm going to say sudo apt-get install -y. I'm going to install a lightweight text editor. I'm going to install net tools so we can get networking information of this machine. And I'm going to install Open SSH server. So I go ahead and press enter. This will install all of these dependencies. Then to get SSH installed, I need to say sudo systemctl enable SSH. I'm going to go ahead and enable it. Then we need to create a firewall rule on the machine to allow port 22. So I'm going to say sudo ufw allow SSH. Then I need to say sudo systemctl start SSH to start it up. So now we have SSH. The next thing I'm going to need is the virtual IP, the IP address of this virtual machine, so that I can access it from Rancher. To get that, I'm going to say sudo ifconfig, and I'm going to record the IP address of eth0, which is 192.168.0.16. So I'm going to go ahead and record that IP address over here. And then I'm going to go ahead and repeat all of this on Linux 1 and Linux 2. So for this Linux 1, the IP address is 17, and I'm going to repeat this process on Linux 2. And finally, we have eth0 for our Linux 2 machine, and that one is IP address 18. So now we have 3 IP addresses, 1 IP for each machine, so we know that they are reachable, and we've configured SSH so we can go ahead and jump into each machine. So what I'm going to do next is open up 3 administrative PowerShell windows, 1 for each machine. I'm going to go ahead and open up one, open up another one, and open up a third one. So now in these new PowerShell windows, we can go ahead and SSH to all 3 machines by running SSH, the name of the user, and the IP address of the machine. So I'm going to go ahead and copy this, jump into one machine, you'll get the SSH prompt, give it a password, and then you are in. And I'll go ahead and do the same thing on the second machine, and then I'm in on that one as well. And I'll grab the IP of the third machine, go ahead and SSH to that, give it a password, and I'm in. So now I'm in on all 3 machines. Now we can go ahead and install Docker on each machine. Now the reason why we need Docker is because Rancher uses a privileged container to bootstrap Kubernetes. Its entire install process is wrapped into a Docker container, and that Docker container runs in privileged mode. It basically takes over the whole VM and bootstraps Kubernetes. It does all the heavy lifting so we don't have to. Everything from setting up the kubelet, the network plugins, using the kubeadm commands, and whatever it takes to get a Kubernetes node up and running. We have to tell Rancher what we wanted to do with that virtual machine. A virtual or a physical machine can be part of 3 roles. It can be a worker role, like a worker node in Kubernetes. It can be a control plane, like a master node in Kubernetes, or it can have the etcd role of running the Kubernetes database. It can also have a mix of the roles, or all 3 of them. Usually you would run 3 VMs for the master nodes to run the master and etcd, and you would have another 3 minimum VMs to run your nodes. In this demo, because I only have 3 VMs, I'm going to bootstrap the master and etcd on all 3 of them, and they're all 3 going to be part of the cluster as well as worker nodes. Now the next part for us to do is to install Docker on each machine, which is very simple. Installing Docker on Linux is extremely straightforward. We're going to use curl. We're going to go ahead and grab the latest version of Docker with this command, and then we're going to take our user and add it to the Docker group and start the Docker service. So we can now copy this command. We can go to our Linux machine, go ahead and paste that. It's going to ask us for credential, and it will go ahead and install Docker on this machine. I'm going to go ahead and fast forward and do this on all the other machines as well. So now I have Docker installation happening on all 3 machines. The next step is to go ahead and add our user to the Docker group so that we can use Docker. So I'm going to say sudo usermod and perform that command. And I'm going to also do that on all the other machines as well. Now I've done that on all 3 machines. I'm going to go ahead and start up Docker by saying sudo service docker start. And now we have Docker running on each of our machines. So now that our infrastructure is ready, we can finally go ahead and install and set up Rancher. Now you can run Rancher anywhere. You can run it on a Kubernetes cluster, you can run it on its own dedicated VM, you can run it on an on-prem machine, or you can run it outside of your Kubernetes infrastructure. As long as Rancher can reach those IP addresses of those machines, you're all good to go. Now remember, Rancher is your source of truth for your Kubernetes cluster, so you want to make sure it's highly available. You want to make sure you persist the data of Rancher as well. So if your Rancher container or instance or server crashes or restarts, you still have your persisted data where all your data and configuration of your Kubernetes environments will live. In this demo, I'm going to keep Rancher outside of my virtual infrastructure and run it on my local machine where it can reach all my virtual machines. Now, setting up Rancher is fairly straightforward if you follow the documentation. You can deploy Rancher anywhere. It can go to cloud environments, it can go to Kubernetes clusters. In this example, I'm going to go with the manual install. And the bare minimum to run Rancher, all you need is a Linux host. So you need a host, whether it's an on-prem machine, a virtual machine, or a system running in the cloud. You're going to want to install Docker and then run Rancher using a container. So you can see it has Docker run -d. It exposes port 80 and 443. It runs a privileged container, and this is the Rancher image. So this allows us to run a specific image of Rancher. We can also mount in a folder so we can persist the data. And once that's up and running, we can log in and go into Rancher and create a cluster and play around with it. So we're going to be running Rancher in a Docker container, and the important part is persisting the data. So basically Rancher stores its data under var lib Rancher. So we're going to want to make sure we create a volume and mount in that Rancher data into the container. So what I'm going to do is I'm going to say change directory into Kubernetes Rancher. So I'm going to go into this Rancher folder, and then I'm going to create a folder called volume. And this is just for demo purposes, because this is going to show how I'm going to persist my data so that if Rancher reboots or dies or crashes, I can easily recover from the data itself. Rancher also has a capability to make backups. Now to run Rancher, it's very simple and straightforward. We're going to say docker run. We're going to run it in background mode. We're going to call our container Rancher server. We're going to mount this volume folder in our working directory that we just created into var lib Rancher to persist the data. We're also going to say restart unless stopped. So in case the container stops, it'll restart it. We're also going to run it on port 80 and 443, and we're going to run it in privileged mode, and we're going to use Rancher image. That will go ahead and start the container. To see that container, I can say docker ps, and we can see Rancher is up and running. Now if I go to localhost on port 443 HTTPS, you can see it is connection closed. It's still not ready. So we just got to wait a while for this container to become alive. And after a minute or so, we can refresh. Make sure you're on HTTPS. You'll get this warning. We'll get to the dashboard where we will be able to paste in the unlock key and reset the password. Now to get the container ID, we can run this docker log command and get the bootstrap password. So what I'm going to do is I'm going to say docker logs, and I'm going to say Rancher server, and I'm going to pipe it out to a file called rancher.log. I go ahead and run that, and we can see here is my bootstrap password. So I'm going to go ahead and grab this password, and I'm going to paste it into the password section and log in. And it's going to ask me if I want to generate a new password. I'm going to say copy that one. I'm going to agree to terms and conditions, running it on localhost, and I'm going to go ahead and say continue. And now we're in the Rancher homepage. We can hit the menu on the side here. We can explore different clusters. We have the cluster management section. We also have virtualization management. We can go to cluster management. We can see our list of clusters. Now it comes shipped with a local K3s cluster. It gives us the capability to create clusters and explore existing ones. We can get a kubectl shell into a cluster. We can download the kube config. We can also view the YAML configuration of a cluster. So every cluster we define, we can store that as a YAML object. It makes it really easy for us to provision new clusters if we wish to do so. Now, one important thing is this Rancher server needs to be reachable by all our physical and virtual infrastructure. So what we need to do is set the server URL so that other machines can contact this. So if we go into the menu and we go to global settings, we scroll down and we look for the thing called server URL, which is right over here. You can see currently it's set to HTTPS localhost. What we need to do is set this to an IP address of this Rancher instance so that other machines can contact the server URL. Now to get the IP address of this Rancher instance, what we're going to be doing is we need the IP address of the instance where this Rancher is running. Because it's running on my local machine, I need my local machine IP. So I'm going to open up PowerShell. I'm going to say ipconfig, and I'm going to look for the Ethernet adapter, that virtual network one we created earlier. And my machine on this network is 192.168.0.2. So I'm going to go ahead and copy this IP, and I'm going to say server URL. I'm going to go ahead and edit that setting. I'm going to go ahead and change from localhost to the IP address of my machine and go ahead and save that. So now when Rancher bootstraps other clusters, it will pass in that server URL so that those machines can contact the Rancher server. Now, the coolest feature of this so far that I've seen is being able to create clusters. So in the cluster menu, I can say create, and we can create a number of different types of Kubernetes clusters. We can bootstrap a cluster on EKS, Microsoft AKS, Google GKE. We can also provision nodes using RKE, that is Rancher's built-in Kubernetes engine. So it can run clusters on EC2, Azure virtual machines, DigitalOcean virtual machines. We've got Linode, we've got VMware vSphere, so if you're maintaining your own hypervisors, and we also have Harvester. We can also do a custom implementation if you're running your own hypervisors. So in this example, I'm going to say custom, and this brings me to the custom add cluster menu. So here I can go ahead and create a new Kubernetes cluster. So I can say this is cluster V1. It then has a member roles section, so we can define here different members that have access to our cluster and what permissions. So I'm just going to keep it here as local default, which is the cluster owner, which is myself. I can define labels and annotations. So here we're just going to say cluster, and the value is going to be V1. So this is our first Kubernetes cluster we're deploying, and this allows you to create labels and annotations for your cluster basically. Then we get to the next section, which is the cluster options. So we can define the version of Kubernetes we want to deploy. So I'm going to deploy Kubernetes 1.21. You can select your network provider, Flannel, Calico, Canal, or Weave. I'm going to pick Flannel, and then I can put Windows support to enable. So this allows me to run Windows node pools as well as Linux node pools. And I can go ahead and customize the network plugin as well. I can also tell it if I'm running on a specific cloud provider. So it knows if it's running in Amazon or Azure, it'll be able to spin up load balancers. But because we're not running in the cloud, I'm just going to leave it as none. Here we can also hook up a private container registry. So if you're running your own Docker registry for images, you can hook it up so it will use your private registry. I'm going to go ahead and disable that. And here we have some advanced options. So what you can do here is you can deploy like an Nginx ingress. You can add metric server. So I'm going to put metric server on by default. I'm going to disable ingress. You can provide a node port range that you prefer to support. This is the default node port range to make sure that there's no ports that clash. You can provide pod security policy support. You can specify even the Docker versions on all nodes, and Docker's root directory. Secret encryption can be enabled as well. And you can also set some backup details for etcds. So etcds has a capability of taking snapshots, which you can push to S3 if you want to have it off cluster in case you have to recover from a disaster. And you can provide like details on how often you want snapshotting to occur. And the last point here is very, very interesting. Rancher has this thing called Authorized Endpoint, which basically means that all kubectl commands that users run may come to Rancher first. And then Rancher will act as a proxy to be able to talk to other clusters that Rancher manages. You can also have users pointing directly to the Kubernetes master nodes and bypassing the Rancher proxy. So I'm going to have this enabled, and I'll show you what that looks like. I'm going to go ahead and click next. And once we hit save, we can now see in the cluster management dashboard, we have cluster being provisioned. And basically it's going to go into this like sort of waiting status because now the cluster has been created in the Rancher database, but we have to bootstrap all the nodes. So if we click into cluster V1, we can see that it's waiting for etcd, control plane, and worker nodes to be registered. And it gives us the registration page. We can then pick what roles we want a node to be part of, and then it gives us a Docker command to register that node. So if you have on-prem machines or virtual machines, you can pick whatever you want that machine to become. So if you're just bootstrapping a control plane, you would untick the worker and just say I want etcd and control plane. This will bootstrap a master node. It gives you a command, and you can go ahead and run those commands on those servers, and they will then join the Rancher cluster and bootstrap. In our case, we're going to pick worker node as well. So I'm going to deploy master and worker to the same machine. This is going to give me a command to copy. I'm going to go copy that. And I'm going to go ahead and paste that on Linux 0. Remember, I'm SSH'd in, and you can see what this is going to do. It's going to run a Docker container in privileged mode. It's going to run continuously. It's using NetHost, so it has full access to the network. It's mounting an etc Kubernetes, so that's where it's going to dump a lot of the Kubernetes configuration. It's running a specific agent of Rancher. You can see here's the server URL that we configured, so it knows how to talk to Rancher. It also has a token and a CA checksum, so it's able to make that HTTPS communication back to Rancher's server. It also has the 3 roles, so --etcd, --control plane, and --worker. So I'll go ahead and run this, give it a password, and it's going to go ahead and download the Rancher image and start up the process. I'm going to copy this command and do the same thing on Linux 2. So I'm going to go ahead and paste that. I'm going to do the same thing on Linux 1, give it a password, and it's also going to go ahead and download the Rancher agent and register itself. And when we head over to machines, we can see these machines are already starting to register. So we already have one over here. We have a second machine that just popped in here, and a third machine. So we can see the registration process has now started. And this process may take some time because each of these machines are now being registered and they're basically bootstrapping Kubernetes. So they'll deploy the network plugins, do all the configuration of the container runtime and the container network. They'll download all the Kubernetes container images and start up all of that. They'll register things like core DNS. So this may take a couple of minutes before our nodes are ready. Now it is probably worth noting that if you're running all of these virtual machines on your machine, as well as the Rancher server, and you're bootstrapping everything at once, your memory consumption might go really high. So it's always worth checking the Kubernetes documentation to make sure you have the minimum required memory for a Kubernetes node, as well as a Kubernetes master node, if you're doing this for production workloads. And it's worth noting all of this because if you're running locally and you're using Hyper-V or Minikube, things might take a little longer to process because you might be running very hot on memory and CPU. So now if I head over to my Rancher homepage, I go to cluster management, we can now see we have our cluster V1 up and running. I can go ahead and click into that. We can take a look at the machines and now they're all green and active. So they're active and healthy. You can also check the provision log to see exactly what happened during the provision phase, if there's any problem registering nodes. This is also very cool. You can take snapshots of your cluster as well. Snapshots allows you to do restores, which you can see over here as well. And the cool thing about Rancher is that we can check out the config, which is all the things we already created here, but the cool thing is we can also edit it as a YAML file. So our entire cluster is defined as a YAML file. So we can declaratively define every cluster we create, and this helps us manage these manifests, and we can even store it to something like Git. So now that we have a Rancher cluster created with 3 nodes, let's go ahead and deploy an example workload. So we'll go ahead and deploy a service with a deployment with a few pods. So the easiest way to access our Rancher cluster is to go to our cluster we want to access, and what we can do is we can download a kubeconfig. And what I've done is downloaded that kubeconfig to my c/temp folder. And let's take a look at that kubeconfig. So we can see when we open it up, we actually have 4 cluster entries defined. So we basically have an entry for each of the master nodes. So we can talk with using kubectl commands to each of the masters. We can also put the masters behind a load balancer and talk to the load balancer if we wanted to. And then Rancher also adds an additional cluster here, which is the proxy, which is basically us talking directly to Rancher. So all kubectl traffic will go to Rancher, and then from Rancher it will be proxied to the master node. We have a user entry, we have a bunch of contexts as well, so we can set our context whether we want to talk to one of the masters directly or the Rancher proxy. And by default it's set to the current context, which is the Rancher proxy. So what I can do is I can go and copy the full path of this file, and then I can create a kubeconfig environment variable, and I can paste the location of that file. And then I can say kubectl get nodes, and we can see now we have 3 nodes up and running. All 3 of them are master as well as a worker node. Now, one of the drawbacks with running our own cluster is that we don't have a built-in load balancer. If you're running in the cloud and you deploy a service type load balancer, the cloud will provision a load balancer for you automatically. When you're dealing with Rancher, you have to set up your own load balancer where you can use something like Metal LB. All other service types are supported. So to deploy some sample workloads, what we can do is we can go ahead and create a new namespace. So I'm going to go ahead and create a namespace, and then in that namespace I'm going to go ahead and deploy a config map. So I say kubectl apply in the namespace, apply a config map.yaml. We can do get cm to get the config map. We can see it's been created, and similarly I can go ahead and create something like a secret, so we can deploy a secret as well. And then I have an example deployment file, so we can go ahead and say kubectl apply a deployment.yaml, and this will go ahead and apply a basic web server with a few pods, and I can go ahead and expose those pods by creating a Kubernetes service. So I say kubectl apply and I apply a service, and now if I do kubectl get all, we can see we have our pods being created. We also have a service type load balancer, and notice that its external IP is pending because an on-prem Kubernetes does not have a default load balancer. We have a deployment where we've set 2 pods and replica sets. We can do kubectl get pods. We can see our pods are now up and running. We can port forward to that service as well by saying kubectl port forward and port forward to port 81. And I'm going to map 81 to 80 because port 80 is in use by Rancher on my machine. I'm going to go ahead and run that, and if I open up localhost port 81, we can see we've successfully port forwarded to our Kubernetes pod. So that's a basic overview of Rancher in a nutshell. Let me know down in the comments below, how do you manage your on-prem infrastructure? And how do you deploy Kubernetes on your own infrastructure? And also let me know down below what sort of videos you'd like me to cover in the future. And remember, if you liked the video, be sure to like and subscribe and hit the bell. And if you want to support the channel even further, check out the link down below to the Patreon, or hit the join button and become a YouTube member. And as always, thanks for watching, and until next time, peace.